Hey everyone, we're going to take a look at paragraph 7.5 solution methods in this video. And I want to illustrate using this image what I think some of you might look like making exercises during this paragraph. And don't worry, I think most of us will look like this when we started with this subject. But I do think that after this paragraph, with my help and some practice, we don't have to look like this anymore, because I'm going to give you a few tips on how you can choose between those two options. Do you still remember this option even? Right, this is what we're taking a look at in 7.4. But the x squared is c is the method that we learned in chapter 5. We could solve quadratic equations already if they were of this particular form. X squared is a number. And then I said if this number is bigger than 0, I get two solutions. The square of 9 or the minus square, or I said square root, sorry. The square root of 9, which is 3, or minus the square root of 9, which is minus 3. If c equals 0, well, then my answer is going to be only x is 0. And the best one, c is negative, smaller than 0, then I had no solutions. We're going to take a look, and this paragraph doesn't really contain that much new theories. It's really more about, well, you should find the solution method for each exercise. There are quite a few now, right? So we have this product is 0 thing that we've taken a look at in 7.4. And we have the equation x squared equals c, which is in chapter 5. And product is 0, we can now also again divide into 3 different methods: the product sum method, the common factor outside of the brackets, and the difference of two squares. We can also use the difference of two squares, and some of you will say, no, not the difference of two squares. I hate that, I find that difficult. For those of you who find that very difficult, I do have some good news. You have a choice whether you use the difference of two squares or whether you're going to use the equation x squared equals c, because there is a choice. I'm not going to show you that in this PowerPoint. I think I will show you this by another video where I can give you an equation which I can solve either with the difference of two squares or the equation x squared is c. And my personal preference is that most people find this easier than this. But be my guest, this works just as well. And the equation x squared is c, we had 3 possibilities, right? I just show you c is bigger than 0, c is 0, or c is smaller than 0. But so, when do I have to use which solving method, which solution method? The book doesn't give you, I think, a very good hint on where to start, so instead I've constructed this table right here. And you see that in this table, I did not use the difference of two squares. If you want the difference of two squares, you must take a look at this table, because the difference of two squares can also be used right here. So I state that I can predict which factorizing method I have to use by taking a look at how my equation is built up. If my equation has something with x squared and x, then I'm going to use putting the common factor outside of the brackets. And you see that there is still a 0 sometimes. In this table, 0 is not regarded a number for the sake of making this division possible. So a 0 is okay. X squared and x. So this is putting the common factor outside the brackets. This as well, this as well. All those examples here I use putting the common factor outside of the brackets. When do I use the product sum method? Well, if I have something with x squared, something with x, and something with a number, and a number right now means something which is not 0. X squared plus 6x plus 8. X squared minus 7x minus 18. You can also see the coloring code that I've used, right? So when I have a red, blue, and yellow thing, I should use the product sum method. When do I use x squared is c or the difference of two squares? When I don't have anything with an x, I should have something with x squared and a number only. X squared is 81. x squared minus 9 equals 0. I don't have something with x here. I don't have anything with a non-zero number here. And here I have them all three. I have x squared, x, and 8. If you can see the differences between these kinds of equations, it's a lot easier for you to predict which factorizing methods you should use in every occasion. Okay? I will upload this table as a separate document as well for you guys to use. And again, this is not in the book, not in Numbers and Space. And the last thing that I'm going to talk about, and I'm going to do this in this video because otherwise I would get a very short video. I think this is quite difficult to just show you by showing you this video. So instead I'm also going to make a video where I'm going to elaborate a few of those exercises. Sometimes when you have something like this, x minus 2, x plus 5 equals 8, I must first, and I know this is stupid to do at first glance, but you have to. You first have to now multiply out the brackets. They've done it in this step. Then they say I have to simplify. These are like terms. So I get 3x here. I want this right hand side to be 0. So I do minus 8 here and minus 8 here. So now I have made the right hand side 0. I must make the right hand side 0 first. That isn't the case here. Here it is. Now what I'm left with is something with x squared, something with x, and something with a number. I can use the product sum method here to find this those factors here, which I now know means x plus 6 equals 0 or x minus 3 equals 0. So x is minus 6 or x is 3. So be careful. If I have something like this and the other side of the equal sign is not 0, unfortunately I should first multiply out the brackets, simplify, make the right hand side 0, use the product sum method, and then I can solve. Right? Quite a few steps, unfortunately, but it is what it is. I will elaborate on some exercises like this in a separate video, or you can ask me later if you have difficulties with those. Okay, good luck to you all and see you later.